All right, in today's explainer, we're jumping into a concept that is, well, it's kind of the secret sauce of all chemistry. It's how we count things we can't even see and, no joke, build our entire modern world from the ground up. This is the big one, so let's get right to it.
So here's how we're going to break it down. First, we'll look at a truly massive problem. Then, we'll see the brilliant solution chemists came up with. We'll check out the map they used to find their way around, see how this plays out when the pressure's on, and finally, we'll connect it all back to, well, everything you see around you.
All right, let's dive right in. To really get why the solution is so clever, you first have to wrap your head around the problem itself. And for chemists, it is a problem of scale that is, honestly, it's almost impossible to even imagine.
So here's the big question, right? How in the world do you count something you literally can't see? I mean, chemists are working with atoms and molecules, the teeny tiny Legos of the universe. And these things are so small, you just can't count them one by one. It's impossible.
Whoa, just look at that number. That's about how many water molecules are jam-packed into a single drop of water. It's insane. So if you're a scientist trying to make new medicines or build better materials, or even just figure out a simple chemical reaction, you have to find a way to bridge this gap. You need to connect that invisible, microscopic world of atoms to our world, the one with scales and measuring cups.
So, what was the big idea? Honestly, it was brilliant in its simplicity. They realized that trying to count single atoms was a total dead end. So instead, they decided to count them in groups. And when I say groups, I mean huge groups.
The easiest way to think about it is this. The mole is basically a chemist's dozen. You know how a dozen means 12 of something? A mole is just a word that means a certain number of something. The only difference is, while a dozen is just 12, a mole is a number on an absolutely mind-bending, cosmic scale.
And this is it. This is the magic number. It's called Avogadro's number, and it is the bridge we were talking about, the link between the tiny world of atoms and our everyday world. It is the number of particles in one mole. And because of this number, a scientist can just weigh a pile of stuff and know exactly how many atoms or molecules they're dealing with. It's incredible.
Okay, so we've got this magic number. But how do chemists actually use it? How do they jump between different measurements, like grams, or the number of atoms, or even the volume of a gas?
Well, they use this simple but super powerful visual guide. The source lecture we're looking at calls it the Y-map, and it really is like a GPS for chemists. It puts the mole right at the center of the universe and shows you every possible route you can take to get from one measurement to another.
And here's how it works. Everything, and I mean everything, starts with the mole, right there in the middle. It's like the grand central station of chemistry. Every calculation either starts here or ends here. From this one spot, you can get anywhere you need to go.
So, let's say you need to figure out the mass of your stuff in grams. Easy. You just follow this path on the map, and the road sign, so to speak, is something called molar mass. That's your conversion key. Okay, what if you want to know the actual number of atoms? No problem. You just take a different path, and this time your guide is that magic number we just talked about, Avogadro's number.
And check this out. For gases, under the right conditions, there's a super direct highway straight to volume. See how it all connects? The mole is the master key. It's the one concept that unlocks and connects all three of these huge ideas in chemistry: mass, the number of particles, and volume. Pretty elegant, right?
And this isn't just some abstract idea you find in a textbook. This is a real-world tool that people use to solve super complex problems, sometimes when the stakes are incredibly high.
Just to give you some context, our source for this is an intense prep course for India's JEE exams. These are crazy competitive engineering entrance exams. And the instructor makes a huge point about this. You might think this stuff is basic, but it shows up. You have to nail these fundamentals. Mastering the mole isn't optional, it's the price of admission.
And this is really where it all begins. Before you can even start using the mole, you have to know what you're looking at. So one of the first things the source lecture covers is this basic classification. Is your molecule homoatomic, meaning it's made of all the same kind of atom, like oxygen gas? Or is it heteroatomic, made of different kinds of atoms, like carbon dioxide? It sounds simple, but it's the critical first step. You got to know what you're counting before you can figure out how many there are.
Okay, so let's pull back for a second. We've seen the giant problem, the clever solution, and the map chemists use. But what's the big picture? Why does this one little concept matter so much to you and me?
Because the mole is more than just a number. It's a translator. It takes the secret code of chemical formulas, stuff like H2O, and translates it into a real-world recipe. It gives us precise instructions that we can actually use, whether we're in a high-tech lab or a massive factory.
Think about it. Without the mole, none of this works. That life-saving medicine you take? The mole ensures the dose is exactly right. The advanced materials in your phone? The mole makes sure the recipe is perfect. Even things like rocket fuel and the food we eat, it all comes down to the mole concept. It's what guarantees we're mixing the right stuff in the right amounts every single time.
Really, what the mole did was transform chemistry from a let's mix some stuff and see what happens kind of art into a precise, powerful science. It gave us the superpower to count the uncountable, and by doing that, it gave us a whole new level of control over the world around us.